So in the last video we saw about particle size and movement of particles. In this video we are going to see some more characteristics of particles in a matter. So let's get started. So let's say you want to drink some lemonade in this hot summer afternoon. What would you do? I would just take some lemon, squeeze it, take some extract out of that and mix in sugar, water and just mix it up all and drink. So while making a lemon juice, I have often wondered, when I actually squeeze lemon, why doesn't the extract stay on top of the water? Why does it actually get mixed up with water? Then I began to kind of research on it, and then I found out that water, not only actually water, but everything in this universe has mass and it's made up of matter, right? And this matter actually has space in between the particles. If you remember in the last video, we saw some particles, right? And those small particles had some space in between them. That space is called intermolecular space. So this space actually allows us to mix things up. And so this space is called intermolecular space, and that is the first characteristics of particles in a matter. So this intermolecular space, as I said, differs from solid, liquid and gas. Is smallest in solids and highest in gas. So that's why you might notice that it's difficult compared to liquids. It's difficult to mix up solid things, and of course you just don't have to worry about mixing gas because it's constantly moving. Now it takes us to the next thing. Have you ever wondered why does a Rubik's cube like this one maintain its shape? Why doesn't it just float like water? Well, that takes us to the second point of characteristics of matter, which is intermolecular force of attraction. So this force is actually abbreviated as FOA, and this force is what keeps solids together. Gases, they just roam around freely, and this force is what actually lets us water and other such liquids flow instead of like mixing up like gases. So now in the last video we saw about density of particles, right? Well, that also has got to do with force of attraction and intermolecular space. So if you actually correlate things, when force of attraction is high, it pulls more particles together, and that in turn increases the molecular density, which is amount of particles per unit volume, and then it actually decreases the intermolecular space. Then obviously, like when more particles are near to each other, the space between them is also less, right? So that is intermolecular space and force of intermolecular attraction. So two things that we learnt in this video is what is intermolecular space and what is force of attraction between molecules. Let's see about some more characters of particles in the next video.